Yesterday was so hectic. I used so much of resources that I literally could see smoke coming out of graphics, Anna.
I think he's getting very old.
Yeah, that's true. He has been with us for 18 months now. The previous one didn't even make it past 10 months.
I know. Graphic cards these days lack the old vigor. So what did you do yesterday?
Oh, I totally forgot to tell you. I can finally distinguish between a cat and a rat. So I went through 3 million pictures yesterday, and after multiple iterations, I have now an accuracy of, guess what? 98%. Isn't that cool? Ah. Don't answer that. I know it's cool. What was your day like?
Me? Well, I was actually writing a story.
Story? What story?
Well, did you know the makers have special abilities?
Special abilities? You mean like superpowers?
Exactly like superpowers. Apparently, they can fly, run really fast, and even disappear. They have this guy called Superman, who's the most powerful being alive. And guess what? Not only can he fly, run fast, and jump high, but he can also shoot lasers from his eyes.
Whoa!
I have been going through all his stories, and now the makers want me to write my own story.
Wow! So you get to write your own superhero story? That's so cool!
Do you think it's possible for machines to become writers just like their makers? Well, let's find out. Machine learning has inserted itself into the fiber of our everyday lives, and most of the time we don't even realize that we are using machine learning. This is not going well. So the other day I decided to appease my hunger for new gadgets by buying a new phone. Needless to say, I was scavenging the internet all night to find the perfect one for me. I woke up today to find that all my social networking profiles are advertising phones. Initially I freaked out. I thought I was bugged or spied on. Have you ever experienced something similar? I'm pretty sure you must have. Well, as you might be aware, these notifications are called recommendations, and they are nothing but an example of machine learning. Generally, when people hear the word machine learning, they picture a robot. Someone like a dependable butler who will obey their orders and carry out their task. Or someone like T-1000 who is out to destroy all humankind. But irrespective of the legion you belong to, one thing that all of us need to understand is that machine learning is not a futuristic fantasy that shall come to fruition in the next 25 years when there will be robots and autonomous car. It is already here. Actually, it has been here for quite some time now. Ever since the 1950s and 60s, humans have been drawn towards the possibility of machine learning from experience. Alan Turing, the famous mathematician and computer scientist, even proposed a test back in 1950, which is now known as the Turing test, to identify the intelligence of a machine. According to this test, if a machine can convince a bunch of people that it is not a machine but a human, then it passes the test. Sounds simple, right? But unfortunately, no machine has been able to do that yet. Though there have been a few dubious claims about certain machines being successful at this test. Over the years, a lot of scientists and mathematicians contributed to the ever-growing repository of machine learning techniques. Scientists like Arthur Samuel, who designed the first computer program back in 1952, could learn as it ran on a system. Frank Rosenblatt designed the first artificial neural network in 1958. The following year, Bernard Woodruff and Marcian Hoff both utilized neural networks to come up with models called Adeline and Madeline. Adeline was used to recognize the binary patterns and predict the next bit, while Madeline was the first neural network model that was applied to solve a real-world problem. Madeline was used to eliminate echoes on phone lines. And guess what? It is still in use commercially. Amazing, right? All those approaches were knowledge-driven approaches, and development hit some roadblocks in the form of computational architecture. But by the 1990s, the landscape in machine learning had changed from a knowledge-driven approach to a data-driven approach, and machine learning application had started becoming mainstream. Well, have you ever received emails like this? I'm sure you have. These are called as spam emails. One of the first applications of machine learning was to build the spam filter, which could separate spam emails from the ham. Well, who hasn't received mails claiming that they are lucky, and as a result, they have been selected for an exclusive trip to an exquisite location, or maybe they have won a lottery of $1 trillion? Wow, it's still going on. I had no idea that many zeros can exist in a number. But one thing to note here is that all spam emails have certain keywords, like you are a winner, you have been selected, offer only for you. Because of these phrases and keywords, it gets easier to flag them as spam. You might be wondering why we need machine learning here. I mean, we can use traditional programming to categorize emails, right? So why go through the pain of applying machine learning? Well, in a traditional programming approach, you would need to go through thousands of emails manually. Then you have to figure out the keywords that are mostly associated with spam. Next, you have to write a detection algorithm to identify each of these keywords. Once you have designed the algorithm, you would test it iteratively. Finally, once you think it is good enough, voila, you go ahead and release it. Only to realize that the spammers have started using offer only for you and offer only for you instead of offer only for you. Do you think the algorithm will be able to detect these messages as spam? Unfortunately, no. So you will have to go back to the detection algorithm and write a new set of rules manually. Imagine having to do this for every sentence pattern. It is an extremely tedious process and sounds next to impossible, right? This is where machine learning comes to the rescue. Spam filters based on machine learning techniques won't require elaborately written rules, as the machine is expected to learn from experiences. So the machine automatically learns which as the machine is expected predictors of spam. How does it do it? By simply detecting unusually frequent patterns of words in the spam examples flagged by the users. So even when the spammers change the sentence to offer only for you or offer only for you, the model automatically notices that the phrase only for you is significantly frequent in mails flagged by the users as spam. Then it automatically starts flagging them as spam. It does all of this without your intervention. Adding to the list of advantages, machine learning programs are much easier to maintain, more likely to have better accuracy, and most importantly, shorter than traditional programs. Fascinated? I'm sure you are. Well, hold on to that, as we have with us a pioneer in the field of machine learning, a subject matter expert and someone who has been working in this field for the past 18 years. Please welcome Mr. Sachin Manji.
Hey all, I have been working and innovating in the space of machine learning for a while now. Even after all these years of innovation, there is still so much to do. But every time I design something new, I am faced with this one question. How did you do this, Da? And I have a flashback to 12 hours of painstaking coding only for one of my friends to go, magic, eh? We have all been there. To the layman, a machine learning by itself is nothing short of magic. So I'm here to walk you magicians through a multitude of areas where this magic is used today and what the future beholds. I'm sure you have heard of these. Yes, these are autonomous or driverless cars that Elon Musk was best known for before he began to hodl bitcoins. Companies like Tesla, Waymo and Volvo have come up with cars that can navigate itself without any human interaction. Quite fancy, right? Technology defined as style transfer is being developed. It enables aspiring visual artists and designers to recompose the content of an image in the style of another. Basically, you can change your selfie to look like Van Gogh painting or change the landscape from fall to winter. Brr, it's freezing. Let's move on. Now this is something soothing. I mean, music just helps me relax and unwind. But do you think machines can create something like this? Okay, let's play a game. You will be given two tunes next. One is created by a machine while the other one is a human composition. You need to identify which one is created by the machine. The correct answer is option A, and to be honest, it was a pretty soothing tune, right? The minds behind that tune, or more specifically the machine that designed that tune, are OpenAI, an artificial intelligence research laboratory. They have created a project called MuseNet, which is capable of producing music in a number of different styles. Apparently, it has the ability to understand music and can also create movements and melodies like a real song. Quite creative, isn't it? Usually, creativity is one of the domains where humans have an upper hand, especially when it comes to writing. But did you know that using machine learning, algorithms have empowered machines to write poems and stories too? Take a look at this poem written by a bot designed by Jack Hopkins. Apart from poetry, computers have written stories too. Take a look at this website. It is a seemingly normal paradise for bookworms, right? But what makes it really special is that this website is exclusively dedicated to books that are written and curated by machines. That's right. All of these books are written by machines. How amazing is that? Although machines can produce some pretty verses and lines, they lack the cohesion and meaning behind real writing. Well, who am I to tell? Maybe I just don't get how the machines feel. I do understand human emotions though, and I feel like you must be wondering, all this is really cool, but how much does it pay me? For that, you need to understand the type of magician you can be. One of the highest paid jobs where you can utilize this skill set of machine learning is in the role of a machine learning engineer, or MLE for short. But since the line between machine learning and data science is very thin, there are some overlaps in the job descriptions of a data scientist, data analyst, and a machine learning engineer. A layman's way to understand the difference between data science and machine learning is that data science is usually related to producing insights, while machine learning is responsible for producing predictions. For a machine learning engineer, the usual output will be a working software instead of an analysis or visualization. Analysts are more concerned with this aspect. While a data scientist will be more involved in using statistics to build models, your role as an MLE would be to deploy these models and turn them into live production systems. You can think of data scientists as roles that create output for people, while a machine learning engineer does it for machines. As a machine learning engineer, your aim would be to create software components that can work with minimal human supervision. Machine learning engineers in essence are an extension to software engineers. One more profile that you can opt for is of a machine learning researcher. This is an umbrella term usually used to define roles like computer vision engineer or researcher, natural language processing engineer or researcher, or a data scientist. How do they differ from machine learning engineers? Well, a machine learning researcher would be more concerned with researching solutions and making advancement in a niche subject domain like computer vision or natural language processing. Ah, keywords, computer vision and natural language processing. You might be wondering what they are. Well, in a nutshell, people who work in the field of computer vision are focused on replicating the complexity of human vision and recognition, while the people working in NLP are more concerned in developing the computer's ability to recognize, interpret, understand and reply using a human's natural language. Both these fields are research driven and can be clubbed under machine learning researcher. One thing that machine learning engineers and machine learning researchers have in common is the fact that they are extremely well paid jobs. In the UK, an ML engineer on average would make £68,750 per year compared to £57,500 of an ML researcher. The story is a bit reversed in the US though, as ML researchers tend to earn a bit higher with an average of 143,000 USD compared to 125,000 USD of an ML engineer. In India, the usual median salary is 7 to 10 lakhs per annum, but someone who has experience of about 4 years or so can earn around 25 to 30 lakhs per annum. Another profile that can be considered as a high paying job under machine learning is that of a human-centered machine learning designer. As the name suggests, these designers are responsible for designing algorithms centered around humans. Through information and pattern recognition, machines can be trained to learn the preference of humans. These algorithms are used by companies like Netflix, Amazon and YouTube to suggest videos and products of your liking. Speaking of products, Nitin, did you find that phone you are looking for?
Not really. The suggestions were just not relevant. Not really. The suggestions were just not relevant. Perhaps the math behind a recommendation needs to be improved. Well, talking about maths, I hope you guys realize that machine learning is not just about writing codes. There is so much more to it. In order to make it in this field, you need to have advanced mathematics skills in linear algebra, multivariate calculus, Bayesian statistics, probability distribution like Poisson, normal, binomial. Additionally, you need to have a basic understanding of data structures, algorithms, space-time complexity, and prior programming experience in Python, R, or Java. Another prerequisite is the knowledge of machine learning algorithms like linear regression, logistic regression, random forest, naive Bayes classifier, K-means clustering. To go with it, you would also need to have a working knowledge of machine learning frameworks like TensorFlow or Keras for model implementation and practical experience of deployment tools like Microsoft Azure, Amazon SageMaker, Google Cloud ML. Phew, you get the idea? If you're feeling overwhelmed, that's okay. It is completely normal to be confused. You might be wondering about where to start and how to learn all of this. Well, that's where we come in. We at Career Labs have designed a curriculum that encompasses all these fields and will help you in upskilling. Our curriculum involves real-world projects, live classes from industry experts, and over 100 hours of content to equip you with necessary tools required to transition into this role. We also have mentors who will guide you in your pursuit for higher studies in Ivy League colleges such as Carnegie Mellon University, University of California, Berkeley, Stanford University, MIT, Cornell University if research and development is where your true calling lies. We can help you, be it higher studies or upskilling. Through our established profile building processes and elaborate network of strategic partners, our programs will give you an edge over the rest. If you would like to hop onto the machine learning train heading towards a $30.6 billion market by the year 2025, Career Labs can help you with all the right documentation. Hope to see you at the station.
So, how was your day? Did you finish your superhero story?
No. Apparently, I need a lot of training before writing a story. Instead, the makers asked me to write a screenplay.
You mean like a movie screenplay?
Yeah, something like that.
Whoa! Sounds so cool. Does it have any title or name?
Yeah, Intro to Machines. That's what I'm calling it.
Sounds familiar. Tell me all about it.